Now that we've derived and proven that this arc length polar form will work, let's actually use it for an example. So we're supposed to find the arc length of the spiral r equals theta squared for 0 is less than or equal to theta, which is less than or equal to 4. So let's see if I've done this. Yes, I have. So here's the spiral right here. I'm doing that with polar plot as a command. And you can see it has a little spiral. And so we want to find the length of that spiral. So let me draw a quick picture. Polar form. And we have the spiral. Let me look at it one more time. Oh, so it goes up and around. Okay, so let me graph that. It's going to go up and around. There's your spiral. So we want to know the length of that spiral. Let me assume R is in inches. It didn't give it in the problem, but I'm just going to help. I think it helps with units. Okay, so arc length, according to the formula, is equal to the integral from alpha to beta square root f of theta squared plus f prime of theta squared d theta. All right, alpha for us is rather obvious because they gave it to us. Here's alpha, here's beta. So I'm going to go from 0 to 4. It's nice when they give it to you like that. And then we want the big square root. And then for f of theta is given to me. It's right here. This is f of theta. So f of theta is theta squared. So I'm going to take theta squared and I'm going to square it. Plus, now I need f prime of theta. I'm going to have to go over here. F prime of theta, of course, would be 2 theta. So in here, I'm going to put 2 theta and square it. Close off my square root, d theta. Not strictly necessary to close off your square root, but it helps. And yeah, we're going to make Maple do that. Yeah, that's what Maple's for. So we will find that with Maple. Let me pull Maple up. So I told it to take the integral of the square root of theta squared squared plus 2 theta squared from 0 to 4. And it gave me this lovely answer, which is correct, but a little bit hard to work with. So I said, okay, that's lovely, but I would like that in decimals, please. And so it gave it to me in decimals at 27.147. So I would say about 27.15 inches. And that's what I would write on my sheet. There we have it. All right. So what if they don't give you the limits of integration? So the one above was rather obvious because they gave us the limits of integration. But what if they don't? Well, that's going to make things more interesting. So when you look at the polar plot on this, you're creating a 3-leafed flower, a 3-petaled flower. So sine of 3 theta. So it begins over here, just having to do with the way this curve works, and it kind of arches its way through. So it begins over at the origin, and it kind of works its way over to the right, over kind of close to that pi over 4, and then kind of arches back, so that by pi over 4, it's kind of back to the beginning. Well, at least it seems like pi over 4, but it's probably not. It's something close to that. So we need to figure that out. So we need to start by drawing. So it goes like this. I'm sorry, I'm not the best polar coordinate drawer. Oh, that's just terrible. Hold on, let me make that better. 1 second. All right, that's a little bit better. I mean, at least this way it goes through the origin. So what I need to know is where does it begin? I need 1 leaf, essentially, of this. Because if I can find the length of 1 leaf, and then I'll just multiply it by 3. Actually, I take it back. They only want 1 leaf. So I want 1 petal, 1 little piece of this. So I want to go from here to here. So let's find 1 leaf using what we knew about trigonometry as well as the polar form. So at theta equals 0, where are we going to be at? R equals sine of 3 times 0, which is the sine of 0, which is 0. So we start at 0, right? So that starts us right here. and then we work our way through the petals. So I want the sine of 3 theta, it's going to come out here and go back down. So it's going to be equal to 0 again. So I want the end will happen when at an angle theta such that r, which is the sine of 3 theta, equals 0. Okay, well that would mean that, so let's think about the unit circle. What are some angles that have a sine value of 0? Well, it happens at the 0 and the pi and the 2 pi and the 3 pi and so on. Those are the values that have sine of 0. So that would mean my angle, which is 3 theta, would be 0, which we already know, that's our starter, pi, then 2 pi, then 3 pi, etc., 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 right? Because it just keeps hopping back and forth. Okay, but that's 3 theta, so that means that theta, well, is 0, which we already know, or pi over 3, see, it's not pi over 4, it was pi over 3, or 2 pi over 3, or pi. So what's happening is this part right here, it comes out, and it swings back, and at pi over 3, it's back at the origin. And then it kind of goes down here, and at 2 pi over 3, it's back at the origin. And it swings through, and at pi, it's back at the origin. So it goes 0, pi over 3, 2 pi over 3, pi. Obviously, the one I'm going to use is right here, right? So that's my end right there. And for the record, that's my start right here. Right there. All right, all of that was just to come up with the limits for my integration. So for alpha to beta, I'm going to go from 0, right, which is the start of my flower, to pi over 3, which is the end of one of my petals. Now for the record, if they wanted you to do the whole flower, you would still actually do this. You would just do one petal and then multiply by 3 because there's 3 petals. I'll make a note of that at the end. All right, so this would be equal to, not equal, but the integrand would be equal to the sine of 3 theta squared, right? There's your f of theta. You know what? Here, let me just real quick, one more time. This is alpha, this is beta, this is f of theta squared plus f prime of theta squared d theta. Okay, so like I said, this is 0, this is pi over 3, big square root. R is right here, so it'd be sine of 3 theta squared, or if you like, sine squared of 3 theta, plus, okay, I need the derivative of this. So the derivative would be r prime or f prime, right? If this is f of theta, this is f prime of theta, which would be 3, derivative of sine is cosine, right, using chain rule. So that means you're going to put 3 cosine of 3 theta right in here, and you're going to square it, d theta. And we totally make Maple do this. This is what Maple is for, right? So with Maple, we will find this answer. So you can see it right here. I took the integral of the square root of sine squared, blah, 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 and it gave me this rather odd function in regards to, remember, some of those you can look up. They all mean different things, so it's just a specific computer algebra system function. So, but when I asked for it at 10 digits, I can see the piece that I want, which is right here. This part we can ignore. That's not doing anything. That has to do with other errors in the computer system. So it's 2.227 right there, 2.227. And if we make everything in feet, which I didn't, but pretend. So if I assume r is in feet, just for the fun of it, then this would be 2.23 feet. And let's make an important note here. If they want the length of the whole flower, what you do is the same method above. Because of the way polar coordinates work, you actually don't want to do 0 to pi, even though 0 to pi would swing out this full flower in terms of a period for the polar function. We don't want to do it that way. So we would take 3 times 2.23, which would be, I don't know, I could find it. 3 times 2 is 6, so it'd be 6.69. There you go, 6.69 feet. So that would be the length of the whole flower. You would do the same method, but just multiply by how many petals there are. All right, that's the end of that. Now we just have to learn how to parameterize with respect to arc length, but that'll be in the next video.